This is the future Failure on project. My name is Rock.
My name is
And
Daniel.
it's Chris.
Hmm.
Right then, next slide. What is nanotechnology? Nanotechnology is the study and manipulation of materials on the nanometer scale, so 1 billionth of a meter. And profoundly influenced the field of engineering. By working at this incredibly small scale, engineers can create new materials and systems with unique properties that are otherwise unattainable at the macro scale, meaning when things are like regular size compared to things that are too small for the human eye. So next slide. How is nanoscience and nanotechnology impacting engineering? First, they enhance material properties. So, for example, strength and durability. Nano-engineered materials can be much stronger, lighter, and more durable than traditional materials. For instance, carbon nanotubes or graphene to composite can significantly increase their strength to weight ratios. Second point, thermal and electrical conductivity. Materials at the nanoscale often exhibit exceptional thermal and electrical properties. For example, nanostructured semiconductors in electronics allow for faster and more efficient devices. Third point, optical properties. Nanotechnology enables the manipulation of light at tiny scales, leading to applications in photonics. Next slide. Second way that nanoscience and nanotechnology is impacting engineering is through electronics and computing. Miniaturization of devices, first point. As the demand for smaller, more powerful electronics grows, nanotechnology allows engineers to develop miniature components like transistors, memory chips, and batteries with improved performance. Second point is quantum computing. Principles of nanoscience are critical for quantum computing, which relies on manipulating particles at the atomic and subatomic levels. Quantum computers, in turn, have the potential to revolutionize fields requiring intense computational power. For example, AI. Third way that nanoscience is impacting engineering is through environmental engineering. First point is water purification. Nanoscale filters and membranes can remove contaminants at the molecular level, making water purification way more efficient. Second point to that is pollution control. Nanotechnology can help reduce environmental pollution by breaking down harmful substances in the air or water. Next slide. The fourth way nanoscience is impacting engineering is through medical engineering and biotechnology. For example, drug delivery systems. Nanotechnology allows for highly targeted drug delivery where nanoparticles can be engineered to release medication directly at disease cells. Second point to that is through diagnostics and imaging. Nanosensors can detect diseases at very early stages by identifying trace amounts of biomarkers in bodily fluids. For example, like imaging techniques like MRIs, which help in detailed diagnostics to show exactly where the virus is and how it's spreading. And the fifth way nanoscience is impacting engineering is through energy engineering. Energy storage and batteries, for example. Nanotechnology enables the development of better batteries and capacitors with higher energy density, faster charging times, and longer lifespans. Second point to that is solar cells. Nanoscale engineering can improve the efficiency of solar cells by enhancing light absorption and energy conversion, making solar energy a more viable alternative to fossil fuels. Next slide. Sixth way nanotechnology is impacting engineering is through structural engineering and construction. For example, self-healing materials. Engineers have developed nanomaterials that can repair themselves when damaged, which could lead to longer lasting infrastructure. Challenges and ethical considerations to using nanotechnology are the safety and environmental concerns. Nanoparticles can pose health risks if inhaled or introduced into the environment, leading to regulatory consideration. The ethical implications are the rapid advancements in nanotechnology and its potential for applications and human enhancement raise ethical questions regarding privacy, safety, and equality. Overall, nanoscience and technology enable engineering innovations across various domains, such as medicine to sustainable energy. The continued research and development of these technologies will further advance the capabilities and scope of engineering. Next.
Perfect. Yeah. So to go into some of the materials that we see with um, our introduction to nanotechnology, we see some of the nanotubes being used, graphene, and nanoparticles that are evolving controlled flight. We start with boron nitride. Boron nitride is a nanotube that is known for its high thermal stability and electrical insulation. We see the use of boron nitride in the engine components, giving these components longer lifetimes by being able to sustain higher amounts of heat. The next nanomaterial we see is graphene. Graphene is known for its ability to protect the airplane from, lightning strikes, and it also serves as a coating to prevent oxidation damage and environmental degradation. They also have been using graphene to observe the lifespan of the aircraft parts by adding graphene sensors that allow you to monitor the health of the parts of the airplane, and could just give you early detections of damage. Um, and then we go on next to the carbon nanotubes. Um, Carbon nanotubes are used to reinforce materials in the aircraft frames and engine, and reduce the weight while maintaining the structural integrity. So, you know, lower weight, you get better fuel efficiency, and it still keeps its structural integrity, meaning it's safe and no one's at risk. And yeah, just performance of the aircraft will also just be better that way. Just one moment. All right. And then we see titanium dioxide. This is the last of the nanomaterials. We see that titanium dioxide nanoparticles are used in aircraft engine parts and are um, used to make photocatalytic and self-cleaning coatings. The um, the coating breaks down organic pollutants and protects against UV radiation. This lowers the maintenance required for these parts, so you have to change them out less frequently, and is very useful when operating at high latitudes. But yeah, those are just a couple of the nanomaterials we see. And we move on to our current applications of the nanotechnology, just, kind of further expanding upon those materials. We see that there are a myriad of ways we can apply nanotechnology on ailerons, which is our main focus from the last project. One of which being nanomaterials that can be used to significantly improve the performance and the durability of ailerons. The nanomaterials offer better strength to weight ratio, corrosion resistance, and better withstand more stress and fatigue compared to the materials we currently use. An example would be carbon, or well, currently usable would be the parts that aren't upgraded yet. But an example would be carbon nanotubes and graphene. Both can be used to create stronger and lighter components, leading to more efficiency. So yeah, we see these nanomaterials being used now, and are beginning to become more common. And here we go, Christian.
Right. So I'll be talking about the future application of nanotechnology on ailerons. All right. The first way we can apply this in the future is through flight control. Nanotech will allow us to develop new advanced sensors and actuators that can easily control how the air flows. We can These nanoscale devices can be used to detect airflow and adjust the position of control surfaces in real time, creating a well-optimized aerodynamic performance, saving in fuel, reducing drag and improving lifts. And this is really crucial in phases such as the takeoff and landing. All right, next slide. Another way is we can apply nanotech is through advanced sensors. Uh, as you said, the nanomaterials such as carbon nanotubes and graphene, they have special electrical and mechanical properties that can improve the sensitivity and precisions of sensors. Carbon nanotubes can be used in accelerometers and gyroscopes to detect the slightest changes in motion with high accuracy, giving us more data in the flight system. And nanotech also allows for smaller sensors, making it lighter, more fuel efficient. It reduces weight and improves overall performance. Sensors at can be added into various parts of the aircraft without adding large amounts of weight. All right, next slide. Lastly, uh, would be a future application would be self-healing. Nanotechnology can be used to improve on self-healing materials. Uh, these components can detect and self-repair damages. This Nanosensors can be embedded within the materials that can monitor the health of the structure. This can give us an early warning, preventing catastrophic catastrophic failure. Another way would be self-healing at a nanoscale can be much faster and more efficient compared to current methods. Nanomaterials can quickly respond to damages and immediately start the healing process. And lastly, nanotechnology can increase the durability and longevity of self-healing materials by ensuring that materials can repair themselves multiple times, increasing the lifespan and reducing maintenance and replacement, saving time and resources.
All right, that's all. Thank you very much. And if we have any questions in class, just let us know and we'll be able to do that. And here's just some of the resources we use. Perfect.
Yes.